Today's lab experiment is physical properties and concentrations. In the lab today, we will be using one sugar solution and making 3 different sugar dilutions out of it, and we will be finding their volume and density. Before beginning this lab, you must know that the way to find density is by using the formula density equals mass divided by volume. And when making the dilutions, use the concentration formula. Initial concentration times initial volume equals final concentration times final volume. You will use this to figure out how much water you would like to mix with the stock solution to dilute it. You also need to know how to find the volume of your solutions and dilutions. When noting the volume through either a graduated pipette or a graduated cylinder, you must read it at the meniscus. The meniscus is a curve formed on the upper surface of a liquid inside of a container. This curve is formed by the surface tension between the liquid and the container holding the liquid. The way you read the meniscus is by holding the graduated cylinder or the graduated pipette at eye level and noting the measurement.
When it comes to comparing stock solution to dilutions, you will notice the stock solution is already prepped for the known solution, whereas the dilution is when you create a less concentrated solution from stock solution. Remember the volume of each dilution, and the initial stock solution should be equal to 25 milliliters, and that the concentration of the stock solution is 20%. During experiment 2 is when you will be making your dilutions and calculating their densities. First thing to do is to make sure you are wearing your goggles and you have all of your equipment. Next, take a full 25 milliliter of the sugar solution and place it into the volumetric flask. You can retrieve the correct amount using a graduated cylinder or a graduated pipette. After pouring the solution into the flask, measure it on the scale. Record this data. Before weighing anything on the balance scale, be sure to zero it out first. After weighing items, when writing the calculations, write the number exactly as it appears on the scale. The last number will flux, so be sure to record the number most frequently shown in the last place.
For the next round, our first dilution, begin using the concentration formula to calculate the amount of water required for your experiment. For example, if your intended concentration is 10%, the formula will be 20% times X milliliters equals 10% times 25 milliliters. After making your calculations, you will get the amount of sugar solution needed is 12.5 milliliters. And to determine the amount of water needed to dilute the solution, subtract 12.5 milliliters from 25 milliliters and you get 12.5 milliliters of water. After making your dilution, record the volume and the mass so that you will be able to determine your density. You will complete this process 2 more times with a different intended concentration to satisfy your formula. After you have gathered all the information, you will be able to make a graph showing the comparison between the density and the concentration of your dilutions. Our graph is shown below. The ideal look of the graph is flexible. It just depends on your group and then what numbers you chose to use. For us, our graph has more of a curve because we use larger numbers, but the only thing required is that your graph suffices the linear aspect of density always increasing or decreasing as concentration increases or decreases.
In challenge 3, we determined the density of the unknown by gathering the mass of the unknown we put in the beaker and divided that by the amount of volume we put of the unknown solution. The result gave us the density of the unknown, so we could take that density and determine the identity of the unknown solution.